Okay guys, here's the intro for this last section and miscellaneous section. Basically the intro for the previous section really suffices for this section. So what I thought I'd do in this little question zero intro is highlight how, remember the times you add rule? So we can go from here, times you add, in terms of indices, to remembering the corresponding log version of times, then you add the logarithms, yeah? And all you have to do is remember that phrase. Okay, let's see how we go from here then, and see how we might get to here, shall we? Just illustrated here. So a to the x. The key thing to remember here is how you can write x. Now I'll just write it down. A, now you can write x as log of, in terms of log a of a to the x, can't you? So that's the power you need to raise a to get a to the x would be x. So that's x there, isn't it? And similarly, the other y you can write as log a of a to the y. Now times you add, so we can just write this as those added together. So that would be a to the log a of a to the x plus log a times a to the y. Yeah, agreed? But if you look back up here, the x plus y, how can you write this? Well, you can write that as a to the log a of a to the x plus y, can't you also? So can you see now that this thing here, this index, a to this index, is equal to a to this index? Yeah, they're equal. So they must be one and the same value. So these two terms must be the same as this value here. So we can just write that down then, can't we? So let's do that then. So what have we got? We've got we've got a to the x plus y, log of a to the x plus y, I'll get it right in a minute. Log of a to the x plus y is equal to log a of a to the x plus log a of a to the y. And this thing here, you can split that up, is equal to log a of a to the x times a to the y, isn't it? So there's our rule. So yeah. So you can see that that's the first number, log a of a number, and that's the second number, so you can replace them by different symbols. So log of the first number times the second number would equal log of the first plus the log of the second. There we are, and you get this generalized rule over here. Okay then, so you can go from one to the other. Now I've illustrated it here, probably not too well, but I think you've seen the gist of it there. So let me just run through it again. I started from here, didn't I? And I could write x as log a of a to the x and y as log a of a to the y. And then I got times, so I could add the indices using the rule for indices. Times you add, and I got that. But looking at this, I could also write that as log a of a to the x plus y. And this thing here, you could split that up using properties of indices again as log of this. Yeah, agreed? And then, but also we've got this thing here is equal to this thing here. So I'll put that there. So again, as I say, it can be confusing, but hopefully you've seen the gist of it. Okay then guys, all the best in this section, and hopefully catch you again in another section. Cheers!